Hi guys. There's the last few people trickling in, so just while we do that, thanks for coming, and I appreciate that you've all stuck around this late into the conference. I know it's the penultimate slot. Has everyone enjoyed the conference?
Yes.
Yeah, there's a good solid yes there, that's great. Right, okay, let's just get going then. So, this talk is sort of about a journey that Pusher went on. We started in October 2017 looking at how we can improve the user authentication on our platform. I then, in January, February, March, published 3 blog posts on the new stack about what we'd done, and then that turned into this talk, which I've done a couple of times in London, but never in America, so first time in America. Yeah, so I'm Joel, I'm a cloud infrastructure engineer, and I work for a company called Pusher. We are based primarily in London, but also have a San Francisco office. How many of you have heard of Pusher? Well, a smattering of you. How many of you could describe what we do to the person next to you? 1 guy, 2 guys. So we're a developer tools company. We do communication and collaboration APIs. The whole point of that is making it simpler for developers to add real-time features to their applications. Our main product is a WebSockets as a service gateway that processes billions of messages per day. That's about all I'm going to say about Pusher. This is more about our journey and not about the company. My Twitter handle is there, so if you've got any questions about any of this stuff afterwards, feel free to tweet me. My email's there, and my blog link is there as well, which has links to the original blog post. So if you prefer reading this kind of stuff, you can go on my blog and read instead. So, back in October 17, my team lead came to me and said, Joel, we should start using RBAC. Now, given this is a security talk, I would imagine most of you know what RBAC is already, but if you don't, it's role-based access control. What that allows you to do is assign permissions to individual users. You define roles that say this person can create and update deployments, but they can't delete them, and then assign it using a role binding to the user's user account. The reason we wanted to do this is because we're sort of faux multi-tenant. There are actually 5 or 6 different teams that use our Kubernetes platform, and while they won't maliciously go and interfere with each other, they could accidentally. It probably wouldn't make anyone popular if ChatKit accidentally deleted feeds namespace, for instance. So what we wanted to do is make sure that we could use permission sets to prevent any accidental interference between the teams. Now, back when we started this project, the Kubernetes project, about 2 years ago, what we did is we spun up our first cluster and we generated a certificate. We gave that certificate the System Masters group, which, if you know RBAC, that has cluster admin, which means it can do literally anything to the cluster. And then, like any good DevOps engineer, we distributed that to every single engineer on the team. I can't believe I got an applause for that. So yeah, there were 30 engineers at the time. We all had this one certificate. The certificate was, actually, I don't think it had an expiry, even better. And we were all logging into every single cluster as cluster admin. Not really where we wanted to go as we started growing the company. So what did we want to change about that? To do RBAC, we needed everyone to log in as themselves. We needed individual user accounts. So I would log in as Joel, my other teammate Phil would log in as Phil. We wanted to be able to do this with group management. Now, obviously, only 30 engineers at the time, but growing company, we're 70 now, want to be 150 within a year. Don't want to manage every single person's user account and permissions individually. So groups would be really helpful for that. We wanted to make sure that whatever we designed would scale. At the moment, we have 11 Kubernetes clusters, but that's because we're only in one region. We've only just gone GA with our products on the platform. So we're probably going to expand that, and over the next couple of years, as we add new regions to the products, there'll be 40, 50, 60 clusters. So we wanted to make sure there's not too much overhead in terms of management in that space. Finally, user experience. This is really important to us at Pusher. We're trying to build this platform that our developers want to use. One of our teams actually uses Heroku when we're trying to prize them off of it. So we're literally fighting Heroku in terms of user experience at the moment. So that was a big concern when we were building this system. So if you look at the Kubernetes documentation, it lists 9 different ways you can authenticate an entity to the Kubernetes API. Not all of those are designed for humans to use. So if you look at bootstrap tokens, for instance, that's for Kubernetes nodes to bootstrap themselves against the API and get their real credentials. There's service account tokens, which are obviously for pods, for your workloads. They're not really going to be used for humans. We looked then at the other remaining 7 and actually ruled out a few more of those. Things like the webhook tokens, the authentication proxies, and Keystone, at the time, we couldn't really find any good documentation for them. We couldn't find reference implementations. The only things we could find documentation and reference implementations for were client certificates and OpenID Connect. So these are the two that we decided we were going to look at and try and weigh up which one would be better for us. So starting off with client certificates, you're probably very familiar with this if you've done any TLS ever. The same sort of certificates you use to secure an HTTPS website, but you have client auth usage in there, and you can use that to authenticate a user or even a service to another service. These have a few problems. So they're issued, and when they are issued by the certificate authority or wherever they're issued, they are issued for a set lifetime. Now, in the real world, when you're using TLS, there is certificate revocation lists and OCSP. Kubernetes does not support these. So the only way that you can revoke a certificate, if you happen to have issued it indefinitely, is to rekey your Kubernetes cluster, which I assure you is not fun. Yeah, I've done it 11 times. Another thing about this is that self-service with certificates is hard. So if you let people self-sign their certificates, what are they going to do? They're just going to give themselves a system masters group, and you've just completely defeated the point of your authority. So you have to have some sort of infrastructure for generating these certificates, verifying that people are who they say they are, which means that not only have you got an authentication system for your Kubernetes infrastructure, you've also got an authentication system for the infrastructure for your authentication system for Kubernetes. So that seemed like a bit of a pain. There are things out there now that can do things like this. Vault, for instance, can do this kind of stuff, but at the time, again, there wasn't much in that space. It wasn't particularly great. Another thing we found with this is that there's no Kubernetes Dashboard support. I know a lot of people don't like the Kubernetes Dashboard, but we use it a lot. Our engineers like to see the little green dials and the CPU and memory graphs, and just generally get a visual overview of what's going on. You can't use a certificate to authenticate with the Kubernetes Dashboard, so if we did that, we'd have to make it read-only and very much limit what it would actually be used for. So next up was OpenID Connect, and if you'd asked me 14 months ago what OpenID Connect is, I would have told you I don't know. So what it is a single sign-on protocol, and as you could probably guess by the title of the talk, this is the option we chose. I'm a very big fan of single sign-on, and as Kelsey said in his keynote this morning, SSO is dope. There are a few problems with it, however. Like certificates, you have a fixed lifetime. They can't really be easily revoked. Google's OIDC implementation, for instance, gives you an hour by default for the ID tokens. It's less than a certificate typically would be, but it's still an hour. Yeah. There are only actually a handful of providers. So if you look at OIDC providers on the web, Kubernetes only lists 3 in their documentation. You've got Google, Salesforce, and Azure. There are a few others out there, I believe Auth0, for instance. But there's not that many options. Most of the engineering stuff at Pusher, we were already SSOing with GitHub, so we wanted to see actually if we could interact GitHub with our Kubernetes infrastructure. Obviously, that wasn't in that list, so that was kind of a bit of a problem for us. But on the plus side, as I say, it's single sign-on, so we can reuse groups. We've got, every engineer's in the GitHub org for Pusher. Every engineer's got a G Suite account, so if we could use one of those to authenticate our users, then we don't have to run our own infrastructure identity management system, which would be great as well. OIDC also has a nice feature that I didn't know about, which is automatic refreshing. When Kubectl, for instance, gets OIDC set up, if you pass it a refresh token, when the ID token that OpenID Connect provides you expires, it can automatically refresh that for you, and so you don't need to log in every hour, which is a pretty cool feature, and we like the sound of that. So how does it work? How many of you have used OAuth 2 before? Yeah, quite a lot of you, so you probably recognize the sort of flow here. OIDC actually piggybacks on OAuth 2, so it's incredibly similar. You've got your website, you see the little sign in with Google button or whatever it is. You click the button, you get redirected off to the sign-in page, you type in your credentials, you log in, and you get redirected back. Part of that redirection back is an authentication code as part of the query string. This authentication code in OAuth 2 is used by the server to act on your behalf. In OIDC, OpenID Connect, what the server does there is exchanges the authentication code for an ID token. This ID token is then what you use to say, yes, I am who I say I am, and provide to, say, the Kubernetes API. These ID tokens come in the form of JSON Web Tokens, or JOTs. They are constructed of 3 parts, the metadata, the payload, and the signature. The metadata tells you how the signature was signed. The payload gives you a bunch of information, and there's an example of that on the right of the screen there. And the signature is used to verify that the payload hasn't been tampered with. If we look at the payload now, you can see it's got a number of fields in there, one of which is the issuer, where it came from, the identity provider, the client it's expected to be consumed by, so Kubernetes in this case, when it was issued, when it expires, and then things like the email, the group information, and the name of the person. Once you've got one of these ID tokens, you can use it with Kubectl. There's a token flag, and you can pass it in there, or you can put it into your kubeconfig. In the background, when you then make a request to the Kubernetes API, Kubectl sets an authorization header on the request. It prefixes the ID token with bearer to tell Kubernetes it's a bearer token. And then when the API receives that token, it validates the JOT signature. Goes off to the issuer, fetches the keys to verify the signature. And once it's verified that the payload hasn't been tampered with, we'll check whether it's expired. If it hasn't expired, it will use the information from the payload to authenticate the user. It then passes off to the authorization, which in this case would be RBAC. If we go back to this slide now, there are still a few problems, as I say. There's this fixed lifetime problem. That could be a problem. Google issues them for an hour by default. That would mean you'd then have to log in every hour if you're not using refreshing. That might get in the way of our engineers, so we wanted to see what we could do about that. There are only a handful of providers as well, and as I said, we wanted to try and use GitHub. We've got GitHub teams set up for every team. We manage our org repo permissions using that. It would be nice to tie that in with our Kubernetes infrastructure. So we looked for a solution, and this is where we came across a product called Dex. Dex, if you haven't heard of it, was a CoreOS project. It has been recently moved into its own GitHub org now that CoreOS have been acquired. And what it does is proxies authentication. It's an identity provider on its own, but it doesn't actually store any identity information. Instead, you configure it to talk to one of many upstream providers, such as LDAP or GitHub or SAML, and even OIDC. We looked at GitHub for this, as it says, but found that the GitHub provider index didn't provide you that much information. It gave you the user's unique ID, which is a numeric string, and that's about it. That's not particularly useful when you want to manage permissions and you want to know who you're assigning these permissions to. You don't want to assign them to a number. So in the end, we actually ended up using Google as our identity provider. As I mentioned, every pusher engineer has a G Suite account, so we're using that now and Google Groups. But that may raise the question, Google's compatible, it's got OIDC anyway, why are you putting Dex in the middle? There are a number of reasons. So the first of this is the control of the token lifetime. By having that issuer there, we can set the token to however long we want. Initially, we weren't using refreshing with this system, and so what we did is set the token to last for 8 hours. That meant that an engineer could come in, log in once in the morning, and work all day without having to log in again. We're now down to 15 minutes, now that we've got refreshing set up, and that means that if someone loses their laptop or their phone gets stolen, then after 15 minutes, we know we've knocked them out. If we disable their Google account, after 15 minutes, we've locked them out even. So that has a number of benefits there. With control of the identity provider, it's actually possible to revoke tokens. Where I said earlier that the API server goes and gets these keys from the identity provider, every OIDC provider has a well-known OpenID configuration document that it can serve. Part of that is the JSON Web Keys URI that it serves. And there you can get the public halves of the keys that sign these JOTs. Dex rotates these on a periodic basis. And so what you can do is, if you control it, you can delete the keys, restart Dex, it will generate new tokens, and when the API server receives a token that was signed with the old keys, it won't be able to get the public half, it won't validate the signature, and therefore will pass that token as invalid and reject the request. So in a worst case scenario, if you want to, you can then log everyone out of the cluster, which can be helpful. If you've already set up an OAuth 2 application in the past, you know that typically you'd have to go onto GitHub or Google and go onto the UI and navigate through all the menus and find where you have to set up a new client. You have to put in a secret and the callback URLs. Dex obviously is configured by us. We run it locally on a centralized cluster. And so we have all this configuration in code, which means that if we want to set up multiple websites to be protected by our single sign-on system, we can actually do that in version control. So rather than having different teams come to us and be like, hey, can you set up a new app on GitHub? They can just submit a PR to our infrastructure repo, we can approve it there, and Google doesn't even need to know. Google only knows about Dex, not the 20, 30, 40 websites that Dex then protects. Finally, the project is open source. And the brilliance of open source is that you can then extend it. So we've actually added a couple of PRs to Dex, and we're running a fork at the moment. The first of these is refreshing. So when we started with Dex, the reason we weren't using refreshing is because the implementation, rather than actually going back to Google to check that the user was still allowed to authenticate, would just say, yeah, cool, that's fine. They logged in once, so they must be able to log in again. So implementing refreshing, it now goes off and checks every time with Google that person's account hasn't been disabled, which obviously means that now works. Secondly, we've enriched it with Google group information. The Google OIDC API doesn't provide you group information by default. So now with this PR in Dex, what we've got is the OIDC flow, and then Dex goes off to the Google Groups API, fetches the group information, and enriches the ID tokens that it provides, giving us that group management that we wanted. So, how do you use this? So the first thing to do, obviously, is set up Dex, and I'm not going to go through that because the documentation on their README is very, very good. They've got a bunch of YAMLs that you can download and apply. Obviously, check those through first. Liz would kill me if I didn't say that. And there's a link at the bottom of their README that says using Kubernetes with Dex. Go through there. It tells you how to set it up. It's really, really simple. Once you've got your Dex instance set up, you need to connect it to the API server. The first thing it needs to know is where you've hosted it. This is so it can go off and get those keys. The second thing it needs to know is which client ID, which audience it's expecting to receive. If it receives an ID token that doesn't match this audience, it will reject it straight away, and it can only actually support one of these. That could be a problem if you're just going straight to an OIDC provider, if you wanted to use multiple sources for identity. But with Dex in the middle, what you can do is you could have people choose between their Google, their GitHub, whatever, and then Kubernetes won't see that. It'll only see the Dex token, and you can have multiple sources for your identities. Then you've got to tell it which username claim to use from the payload and which group claim to use from the payload, and that's it. Once you've got the Dex instance and the API set up, you can now start using it with kubectl. Kubectl, I'm sure you've all seen a kubeconfig before. Normally you have a little pointer to a CA file and a certificate, identity certificate. With OIDC, you give it a few more bits of information. You give it the client secret, which is not particularly a secret, but more a pre-shared key. It's part of the OIDC spec that people often confuse. They're like, oh no, this needs to be really kept secret, but you need a couple of bits to make that actually useful. You need to be hosted in the right place. So if your application is using HTTPS, which it should be, and you have the client secret, that's fine, but people can't really man in the middle when you've got TLS anyway, so it doesn't need to be that secret. You then need to get yourself the ID token that identifies yourself, those JOTs that I talked about earlier, and if you want to do refreshing, you'll probably need a refresh token too. Now, kubectl doesn't have a login command. Kubernetes doesn't actually provide you a way to authenticate with an OIDC provider. That's something you have to go and solve yourself. Dex, on the other hand, they've kind of solved this problem. They've helped us out a bit. They've got an example application that can interact with Dex or any OIDC provider. And what it does is it runs a small binary on your local machine, sets up a small web server. You go to your browser, you do the login, and then it displays the information back to you as a web page. So you can see at the top there, it displays the ID token that you need, the information from the payload, and the refresh token at the bottom. Great. Copy and paste that into your kubeconfig. If you've got refreshing set up, you never need to do that again. That's not great when you want to roll it out to 30, 50, 300 engineers. We wanted to make sure the UX of this project was really good, as I've said before, so we built our own tool. This is called ChaosOffInternal, and it's actually an extension of this example app. The example app's only a couple of hundred lines. This is about 300, and just enriches it a little bit. So what it does, instead of having to provide all of the configuration as command line arguments, it uses the fact that our engineers all log into Vault when they join the company to store the configuration in Vault. When it starts up, goes off to Vault, fetches the client secret, the issuer URL, the CA certificate that it needs, and then does the process from there. Starts that same little web server, opens your browser to start the login process, you log in, and then it redirects back, exchanges the ID token, and then builds your kube config for you. So when a new engineer joins the company, all they need to do is sign into Vault, download this KSORF binary, give it a list of clusters that they might want to interact with, and this builds a complete kube config for them with context and clusters and the credentials that they need. So this is where I'm now going to try a live demo. And I'm just going to switch on to my tethering if it's there. It's not. OK, we'll try it on the public Wi-Fi. OK, how's the text size there? Good? Yep. So to prove I'm not cheating, the first thing I'm going to do is delete any existing configuration. Then if I do a get node, you'll see that it's trying to talk to localhost. That's the default behavior for kube control when it's got no configuration. Now what I'm going to do is run our little KSORF binary, give it the name of one of our clusters, the Apatus, and see what it does. So you can see it's pointed this browser now to Google straight away. I can now log in because I've got a pusher.com email. And of course do my 2FA. No. And you can see on the right there, it's got you've successfully authenticated, and on the left, it says it's written a config to users joel.kubeconfig, and it's logging succeeded as joel.speed@pusher. So now, what I can do is set the context to that cluster I named, and let's have a quick look at the config that it built. So you can see there, it's got all the credentials, it's downloaded the certificate for our CA certificate from Vault, set up the context and the clusters, and now we can use this config to get nodes from an existing cluster, proving that I've logged in, hopefully. I'll just exit out of that stuff. Go back to separate. Cool. So that kind of wraps up the command line experience for single sign-on. Obviously, that KSORF tool is very specific to Pusher, especially the Vault integration stuff. So what I've done is I've created a slightly more abstracted version of that and put that up on GitHub. That's basically the same thing, but all the Vault configuration that you'd get actually ends up just being command line arguments. If you wanted to build a similar sort of experience, that might be a good place to start. So the next step of this journey was the Kubernetes Dashboard. Love it or hate it, I know a lot of people say just don't use it. Our engineers, as I said earlier, like to use it. They like the little green dials. So we wanted to make sure that we could use this. In version 1.7 of the Kubernetes Dashboard, they introduced a login view. The login view, you can upload a kube config if you want to. You can copy and paste a token in, or you can press the little skip button and not log in at all. Obviously, that's not great. When you're using kube configs, you can only actually use basic auth. You can't use certificate data or anything like that. And with tokens, again, if you've got it in your kube config, yes, you can copy and paste it, but who wants to do that 10 times a day? There is a solution, however. The auth header that I mentioned earlier when we were talking about how kubectl interacts with the API server, if you make a request to the Kubernetes dashboard with this auth header, it will then proxy that auth header through when it makes requests up to the API server. So somehow we wanted to make sure that every request to the dashboard had this authorization header in it. This is where we get the bit the OAuth proxy come into the story. So we've been using this for a while to protect a number of things. We've got manuals and runbooks, a bunch of legacy infrastructure that has single sign-on. So we knew the project well. I knew roughly that it could do what we wanted, given that I knew it had an OIDC provider, so I could connect it up to our Dex. I didn't know whether it was actually going to be Kubernetes compatible or not, though. Turns out it wasn't quite, but a couple of PRs later, and now it is. So now with these PRs, what we can do is we can set it up to actually provide that ID token from the OIDC provider in the authorization header that we can then proxy through to the Kubernetes dashboard. You can use this in two ways. There's the upstream way and the auth request way. In the upstream way, you have your ELB, the Ingress controller, and then the OAuth proxy and the Kubernetes dashboard sort of in a line. What that means, though, is you have to have the OAuth proxy for every instance of your Kubernetes dashboard. So if you have it on multiple clusters, you're going to have to configure Dex to know where each of those are. If you want to protect more than just the dashboard, say Prometheus or Grafana, you're also going to have to put one in front of those. So that's not particularly great. The alternative is this auth request way. So the Nginx Ingress controller has something called an auth request module. And what it can do is when it receives a request to an Ingress object that is protected by single sign-on, it goes off to your OAuth proxy, provides a sub-request, and that sub-request will tell Nginx whether you are logged in or not. If you're logged in, great, it proxies the request through, proxies that authentication header that I talked about. If not, it redirects you through to then start the login process. This is configured on the Ingress object, as I say. I'm sure you're used to adding annotations to your Ingress objects. There are 3 you need for this. The first of that is the auth URL, the URL provided, or the endpoint provided by the OAuth proxy. This is the one that returns either a 202 or a 401. In the case of a 202, you're logged in, it has the authorization header. This configuration snippet at the bottom here takes that authorization header and proxies it through to the dashboard. In the case of a 401, Nginx sends a redirect for the sign-in URL, which is the second annotation there. So, time for another quick demo. So, since I was logged in already, let's go incognito for this one. Maximize that. So what I'm going to do here is type in, if I can type, the URI of one of our Kubernetes dashboards. So you can see I don't see anything straight away. I go straight to Google. Again, I can log in. TFA. And then I get redirected back, and I should end up straight on top of the dashboard. So you can see up here in the right, I'll just zoom in a bit, that says up there, logged in with auth header. The Kubernetes dashboard has detected that authorization header and is proxying that through when it makes requests to the API server. And I can now go through and look at nodes and stuff. I am now logged in as me. Okay. There is some sad news, however. About 2 weeks ago, I got tagged in an issue on the OAuth proxy. The Bitly team have actually decided they're no longer going to work on it and have archived the project. This issue is about finding a new home for it, and at Pusher, we have decided to volunteer to take on that responsibility. We've got a good understanding of the code base. The couple of PRs that I've written are quite extensive through the code base and touch a lot of it, so I've got a very good understanding of the project myself. There are another few people I've spoken to on the issue who have also volunteered to help maintain the project. And I've now spoken as well with Cheryl Hung, which is Director of Ecosystem for the CNCF, and Brian Grant, who's on the Technical Oversight Committee. And in the new year, we're going to try and get that adopted as a CNCF project. So yeah, although I've mentioned this project that is kind of archived, it is not dead. We are taking on that responsibility. We're going to try and get it into the CNCF, and hopefully we can build a new community around it. There's a couple of hundred PRs and issues that are open. People are using this thing. It's got 4,500 GitHub stars. We want to keep that alive. So just to quickly recap what I've gone through now, every engineer at Pusher, when they log into our system, has their own account, which means we can assign RBAC permissions to them. We've got group information coming from the extensions that we've added to Dex. We've got short-lived tokens. They're only there for 15 minutes. So if someone loses their laptop or gets their phone stolen, then we can log them out of Google and get them out of our infrastructure within 15 minutes. The thing we've built is scalable, so when we add these new clusters, we don't need to reconfigure anything. And in terms of UX, the binary that our engineers download, they run that once. They never have to run that again. The dashboard, whenever they're not logged in, they get automatically redirected. I think that's probably the best we could achieve. If you have any better ideas, please do let me know, because I am interested. I would probably get shot if I didn't mention. I know everyone is hiring, but Pusher are hiring. If you live in London or fancy emigrating to London, we are hiring. We can sponsor visas. We've got not only Kubernetes openings, but we've got openings for back-end engineers in general. In terms of Kubernetes, we're doing lots of interesting stuff around custom controllers at the moment, especially using the KubeBuilder project. Check out my Twitter. I tweet about all the stuff we're doing loads. And come have a chat with me if you're interested. This final slide has got a bunch of links, mentions of the PRs that I've mentioned in this talk, and just details again if you want to talk to me. Yeah, thank you very much for listening. Any questions? Do we have time for questions? Yeah?
You mentioned that the token security
So the question there was the fact that the tokens are 15 minutes long, does the dashboard get refreshing? So one of the PRs to the OAuth 2 proxy, 621, does that say at the bottom? Yeah, 621 actually implements refreshing in the OAuth 2 proxy. So that now stores the refresh token in the cookie as well. So basically it's got this encrypted cookie. Inside that you've got your ID token and the refresh token. And then when it gets to 15 minutes, because every request to the dashboard has to go and get this 202 response, it can then perform the refresh cycle once you get past your 15 minutes.
To remove the token that is already there, do you go to Dex URL for it?
So the question was to remove the tokens that already exist. So if you're using some upstream provider like Google, if you go and disable the Google account, when it gets to refreshing, that refresh request will get denied. If you don't want to do that, you have to revoke the keys, which if Dex is running in Kubernetes is a case of deleting a CRD. If it's running outside of that, it will have something like Postgres or SQLite. You can just go into the database and delete them. There's no stored list of the ID tokens, so you can't just go and delete them. That's not what the check does. It doesn't go and check that it still exists. It goes and checks that the signature is valid. Those are never stored in the system. Anyone else? Yep.
It wasn't clear to me where you got the group's information from, if you can't get it from Google.
Sorry, yeah. So the question there was where it wasn't clear where we got the group information from. So Google's OIDC implementation doesn't return you in the ID tokens the groups list, but there is a Google Groups API. So PR 1185 on Dex is the code for that. What it does is it uses a service account to talk to the Google Groups API. That's a completely separate API. It takes the username that it gets from the ID token, lists their groups, and then uses that to enhance the ID token there. Yep. So the question was about using RBAC with groups. So when you're defining an RBAC role binding or cluster role binding, in the subjects field, there is subject kind, I believe is one of the fields. That can be user or it can be group. If it's group, then it will be in this case, email of the group. So say we've got group1@pusher.com, we would put that as the subject group1@pusher.com, and everyone in that group would then have the permissions from that role binding. Yep. So logging into different clusters is the question. We actually host all of this centrally, and we use the same credentials for every single cluster. The thing is with authn and authz, I am Joel, I'm always Joel. It doesn't matter where I'm going with that. So we decided for now that we would have a central authentication cluster, and all of the clusters would use that same central auth. You could separate production, but really, is there a need to prove myself on the different infrastructure? Given that the RBAC can be different on each cluster, it doesn't particularly matter. Is that okay? Yeah.
Are you running Dex and OAuth inside of Kubernetes, or you have own separate?
We originally ran them on a separate infrastructure. So we originally ran them on their own EC2 instances. We're now running them in Dex, however, so we have them in 2 clusters. We have 2 central clusters that we call global for stuff that doesn't need to be on every region. And in there we have Dex and the OAuth 2 proxy. That obviously does create a bootstrapping issue. We have a Terraform module that can create us a certificate in a break glass emergency team thing. So the infrastructure team have a KMS encrypted secret that they can use with this thing to get an hour-long certificate if we need to. So if our Dex stuff does go down, we can also get into the clusters using that break glass approach. Yeah. Should probably call it there, but I'll hang around outside if anyone's got any more questions.